So section 1-2 is all about functions and graphs. There's a whole bunch of information here, so if you need to take it in pieces, do that. Okay, so first of all, we talk about a function. This is just copy and pasted out of your book, but you need to learn how to kind of read your definitions and get what you need to from them. A function from a set D, domain, to a set R, range, is a rule that assigns to every element D a unique element in R. I would always say, in order to be a function, the domain cannot repeat. The domain cannot repeat. Okay? The domain is the set of all output values or the set of x's. Domain is your x values. Range, sorry. The input is the domain. The output is the range. My bad. I got to think rather than just read what's in front of me, right? All right, so your domain are all the set of the x values. Sometimes we don't always use x, that's why it's input versus output. But typically we use x and y. So maybe you go x values or input, y values, output. All right. A lot of times we do talk about independent and dependent variables. Think about when you make a table, which ones do you pick? You pick the x's. You might pick 1, 2, 3. You might pick -1, 0, 1. X is the independent variable. Y depends on what you choose for x. That's why we say x is the independent because you start with x. Y is the dependent because the y value depends on the x value you're talking about. Independent variable is x, dependent is y. You've seen a lot of the different diagrams through the years. You take an input x, plug it into a function, and you get y, or the f of x is the output. Don't worry about copying all the goofy pictures. This is just kind of in your book, though. I do like this, though. When we were talking about how y is a function of x, y is the equal sign, a function of x, f of x. So that's kind of how you can remember that. All right, so example 1 is just area of a circle. It wants you to write the area as a function of its radius. That means that you want what's the area formula only using the radius. Well, that should be pretty easy, right? A equals pi r squared is our area function. And so as long as the left side is A and the right side only uses R, you're golden. What if it said find the area, as the function, as a function of its diameter? Okay, so we know the area formula of a circle is pi r squared, but what if I don't want r, I only want to use d? I need to find a relationship between r and d. Well, we know that your diameter is twice the radius. So what that means is I want to replace r with d. So what does r equal? R is half the diameter is r. So I can substitute half of d in place of r. So this is area as a function of its radius. This is area as a function of its diameter. So it kind of shows you the difference. The question didn't ask for the diameter. I just wanted to show it to you so you could see the difference. Okay, domain we know are the x values. The natural domain are the values of x that give real y values. Okay, so you think about real y values, so that's not going to incorporate like the imaginary values and things like that. Okay, and this just gives us all sorts of different notation. You are used to this notation with greater than and less than. We're going to focus this year on the interval notation. Okay, so let's think about how it looks on a number line and how it looks using greater than, less than, how it looks in interval notation. So if A is not included, we use an open circle. That's just, this is where X is in between A and B. That's how I would read this. X is in between A and B. It doesn't include A, it doesn't include B. Those are both open circles in between A and B. Parentheses correspond to a not equal to, like just greater than or just less than. Parentheses, greater than or less than. Now look over here on the right side. If it's filled in, that means it's less than or equal to. Okay, that's a bracket. This bracket means that the value is included in the notation. Parentheses, not included. And this is how this notation is used all throughout the year. You'll get a whole lot better. Okay, we call A and B boundary points. Everything in between, interior points. Sometimes we use union. Very rarely do I use intersection, but we're going to use this U a lot. And you'll see here in just a second. All right, you might want to get your graphing calculator out. Graphing stuff without a calculator will be important this year, but we'll also have the calculator to help us when we get stuck. All right, so I want you to think about y equals x squared, the general graph touches at 0, 0 and goes up forever. Now, if we were to list every single x value, that means every x value going to the left, every x value going to the right. If it goes if there's an arrow here, it goes all the way to the left. Domain is all the way from the left to the right. And if there's an arrow, we do not include it. So we say negative infinity to positive infinity. Because this graph would go all the way to the left eventually and all the way to the right eventually. So all the x values included are all to the left, all to the right. Now I want you to think of range going from the bottom to the top. Okay, so because domain are x's, it goes left to right, always goes smallest to greatest. Range is the y, so it goes bottom to top. What's the very bottom of this graph? The bottom y value is 0. Since 0 is included, I use a bracket. How far up does the graph go? All the way up to infinity. So that's our natural domain and range. Okay. People forget how to graph 1 over x. We call this a rational function because it's creating a ratio. 1 over x, anytime your x is in the denominator, you're going to have asymptotes. This is the most basic rational function. So there's a vertical asymptote at x equals 0, because when x is 0, that creates 0 in the denominator, which cannot happen. So I'm going to cross this out. I cannot include the y-axis or x equals 0 in my graph. This is our vertical asymptote, VA. We also have a horizontal asymptote, which we'll get to that a little bit later. But our horizontal asymptote is at y equals 0, because our y values, as x gets really, really big, I'm taking 1 divided by a really, really big number, and my y is getting smaller and smaller and smaller. So hopefully you remember this particular graph. If not, I would maybe kind of do little sketches along the side. I'm doing mine kind of big just so you can see it really clearly. Okay, so how far to the left does this graph go? Since there's an arrow, that's all the way to the left, negative infinity. Now, if I trace the graph, how far to the right, notice it doesn't include 0. So what I'm going to do is it goes up to 0, but does not include it, so I use a parenthesis. Here's where I'm going to come up to my union. I'm going to union this region, the left side of the graph, with the right side. This one picks up where this left off, just to the right side of 0, and it goes all the way to the right. So what this does is basically takes 0 out of the domain, because I'm not including 0 on the left or the right, so it just takes 0 out of the domain. How about the range? How far to the bottom does it go? This has an arrow going all the way down. So I'm going to go negative infinity. This goes all the way up to 0, but doesn't include 0 because there's also an asymptote there. So my range actually looks exactly like my domain. So it goes all the way to the bottom. It goes all the way to the top, but it does not include 0. The next one's way easier. This is the hardest page, I think. Square root of x. So your square root of x is just the top half of a sideways parabola. It starts at the point 0, 0. So when I look at the domain, left to right, what's the far left x coordinate? 0. How far to the right does it go? All the way. All the way is always infinity with a parenthesis. That's it. Range is bottom. What's the bottom part of the graph? Starts at the y value, including 0. Oh, shoot. We should have included that. So you could have yelled at me if you're in class. And it goes all the way up to infinity. Please mark any questions in your notes if you want to talk to me about them anytime the next day. Or just text me and we can talk about it too. All right, so what just happened from here to here? You can see some translation going on. This is moved and reflected. All right, so I'm going to take this basic graph and it's reflected, the negative x is reflecting it. And so that's going to go, so this would be the square root of negative x. All right, and think about this point here is the value where x is 0. What value of x here would create a 0 if you plug in what value for this x? I'm kind of going all over the place here. This actually goes to the right 4. So this is your square root of negative x. This is the square root of 4 minus x. All right, so using this particular graph, let's look at domain. How far to the left? Left is an arrow, so that's negative infinity. Always double check, you should have negative infinity. If you use both negative and positive, you should start with negative because it's always the smallest value first. How far to the right does it go? We're using the x-axis for left and right. So that's 4, and it includes 4. Okay. What's the bottom? The bottom of the graph is 0. How far up does it go? All the way up to infinity. All right, let me erase these. Remember, anytime you need to pause the video to look and kind of ponder and think about, jot down any questions in your notes. All right, you're going to see this next equation quite a bit. And what we'll do is kind of work through it first, and then we're going to graph it using your graphing calculator. So if I wanted to get rid of the square root, and I square both sides, and then I add x squared to the other side, we'd get x squared plus y squared equals 1. Now, hopefully you would remember when x and y are both squared with a plus, this is a circle, this is r squared, so radius is 1. This full equation is a circle. Okay, let's work our way backwards. If we were to solve for y, subtract x squared and take the square root, one of the things I get really, really cranky about, when you take the square root of an equation like this, you always need a plus or minus. You always need a plus or minus when you take the square root of an equation. Notice though, this equation doesn't include it. It's just talking about the positive side. It's talking about the positive portion of the circle. See, this top is y equals 1 minus the square root of 1 minus x squared. The bottom part of the circle is negative square root of 1 minus x squared. So if you were to go on your graphing calculator to y equals, and you type in, this part is given, the square root of 1 minus x squared, and graph it, you would just see the top half of the circle. And that connects at negative 1, 0, and 1, 0. So domain is left to right. What's the far left side? Negative 1, and including negative 1. How far to the right does it go? Positive 1. What's the bottom of the graph? The bottom y value is 0. How far up does it go? 1. And that's domain and range. That gives you some pretty good, I'm hoping, understanding, but please ask me questions on anything you have questions over. Okay, talking about your graphing calculator, the graph viewing skills. There are 4 things you need to be able to do. When you put a graph into your graphing calculator, you need to be able to recognize that a graph is reasonable. That means you better know your basic graphs, parabolas, circles, lines, stuff like that, so that you can make sure that you see all the important characteristics. All right, you need to be able to interpret where's your max and mins, and that's going to be really helpful in using your calculator. And this one, recognizing graph or failure. There's times when there's a vertical asymptote that you might not see that the graph goes on forever. You need to understand the types of failures as we get to them. And I'm going to point them out, but it's also up to you to remember them. Even and odd. Okay, so I want you to think of the most basic even number. And I'm going to say, take that number 2, even number, and make it the exponent. if I look at this graph, y equals x squared, oh, what happens if I plug a negative x in for this function? What happens to the negative if this is an even number? The negative goes away. If it's an even function, ooh, this is, talk about a graphing error, this is a textbook online error. If you plug a negative x into the function, you just get regular f of x out. So let's, oh, and the other thing I want to point out is the symmetry. All even functions, what happens, what can I flip this graph over and get the same graph? If I flip this over the y-axis, it has y-axis symmetry. Very important. So when you plug a negative into an even function, you get the original function, and it's symmetric to the y-axis. All right, what happens if we take an odd function? Oops. Let's do x to the third so we kind of review what that graph looks like. I'd have a whole bunch of things I'd be showing you if this were in person. I like to dance around. Okay, what happens if you plug a negative and there's an odd exponent? You just get the opposite. You keep that negative, and it's just the opposite of the original function. If you plug a negative x into an odd function, you get the opposite of the original function. What does x to the third look like? All right, so maybe let's think about x to the first, straight line. X to the second, parabola. X to the third takes the straight line and just kind of wiggles it. It has some of the same properties though. The left side goes to negative, the left side goes to negative, the right side goes to positive, the right side goes to positive. All odd exponents kind of share similar qualities. All right, so if I look at this, this doesn't have symmetry over the y-axis or over the x-axis. This has what we call point symmetry. This has symmetry over the origin. So just kind of notation for you to remember. Okay. So how to actually go through and determine if something is even or odd algebraically. I have this covered up. Let me do this. Okay. So in order to prove even and odd, you must plug a negative x in. And we just kind of talked about this, but when you square a negative, the negative goes away. Anytime you plug, if the f of negative x equals the original function, because see, x squared is the same as the original. If f of x and f of negative x equal the same thing, that's what this kind of big mess back here was talking about. If f of negative x equals f of x, it is even. This is an even function. So first plug negative x in, negative x squared plus 1. When I square the negative goes away. This is the same as the original. Therefore, remember those 3 little dots mean therefore. Therefore, it is even. All right. If I plug negative x in here, I get the opposite of x. Now, what I want to kind of point out, if f of x equals x, what is the opposite of f of x is negative x. Notice this is the same as the opposite of f of x. If f of negative x equals the opposite, therefore it is odd. All right. Okay, so I'm going to kind of break this last one up a little bit differently. We said earlier, if f of negative x equals f of x, the original, it is even. If f of negative x equals the opposite of the original, it's odd. Every other situation is nothing. So let's look at this last problem. First of all, what is f of negative x? Negative x plus 1. Does this match the original equation? No. So it is not even. What is the opposite of the original function? Opposite of the original is negative x minus 1. So notice everything hinges on f of negative x. What do these two equal? Because f of negative x did not equal the original, it's not even. But f of negative x also does not match. These two are not the same. So this means it's not odd. Therefore, it is neither even nor odd. It is neither. So we had even, odd, neither. But you're trying to match these two things up. You're matching either f of negative x to the original f of x or f of negative x to the opposite of the original. If one of these two is not true, neither. All right, the next two have to do with piecewise. People usually struggle in the beginning with piecewise, but then they really kind of fall into a pretty good pattern with it, okay? I think it's helpful to understand there's two parts of piecewise. The first part is telling you what the function equals. Y equals negative x. Let's put the right side on hold for just a minute. All right. So if I graph y equals negative x, this is a line with a y-intercept of 0 and a negative 1 slope. All right. So here, I'm going to use my line feature. This is the entire equation. I only want this equation, though, for where x is less than 0. This portion talks what part of the x-axis will you use of the entire thing. So where is x less than 0 is right here. So I'm just going to use to the left of where x is 0, all values where x is less than 0. And then I'm going to put an arrow on the left side. If there is graph paper, you should make darn sure this part is, every point where it's hitting should be accurate, or I'm going to take a point off. Okay, so be careful. All right, the second equation is y equals x squared. But I'm only going to use it for values where x is 0 to where values of x is 1. So remember, x squared is that parabola shape. I'm just going to plug 0 in, and I get 0. Notice this was an open circle because it was less than, it did not include 0. This part, though, is going to go over top of it, so it's going to fill that in. So I'm just going to use from here to here of the graph, just from 0 to 1. And I'm going to include 1, so it's a solid circle. It's even hard to really see that that's curved, but you know it should be. And then y equals 1 is just a horizontal line where y is 1, but I'm going to use it only for values where x is 1 and greater. So I'm going to start here and go to the right, and that's your piecewise. So we had negative x for this portion, x squared for this portion, and 1 for this portion. So it's like graphing 3 separate functions, but only using a piece out of each one. So this is going backwards. They're giving you an equation, and they want you to come up with or they're giving you the graph, they want you to come up with the equation. So first of all, I see 2 pieces. So I'm going to create 2 sections. This is the function, and this is the part of the x-axis I'm going to use. All right. So first of all, if we'd extend this just to kind of see, this is a line with a y-intercept of 0 and a slope of up 1 over 1. So 1x plus 0 would be like our y equals mx plus b. I only put this part, but I don't really need the 1 because 1x is the same as just x, and I don't need 0 because I don't need to add 0. But where am I using, what part am I using this for? I'm using it where x is in between 0 and 1. Notice 0 is included, but 1 is not. All right, now let's go to this next one. All right, so this one, if I'd extend it, see, notice I go down 1, left 1, down 1, left 1. I can definitely tell this will intersect at -1. And it's also got a positive 1 slope, 1x minus 1. Otherwise, we'd have to use this, this is 1, 0. I use this point and this point to come up with a line using my point slope form, solve for y, because I need this part for my function, because this is the y equals. So you've got to get y by itself for this. What part of the graph is being used between 1 and 2? All right. Notice 1 is included, and so is 2. So I'm going to go in between 1 and 2, including both. All right, absolute value is defined as a piecewise. First of all, let me just see. So this is your absolute value, right? I want you to think about, if we just graphed y equals x, the most common line ever. Okay, pretend that just crossed through the origin. What does absolute value do to all values? It makes them all positive. That means all y values need to be positive, so it takes all of these and it reflects it over the x. That's why absolute value of x, as long as this is an x inside, this will be a V shape. And because it's like 2 different lines, one with a negative slope, one with a positive slope, I can cut it off at 0 and do my either less than 0 and greater than or equal to 0. So it's negative slope on the left side, positive slope on the right. So if we just use this and transform, let's think about anything connected to the x moves at the x direction. And remember, it's always the opposite when it's connected to the x. So the x minus 2 moves it to the right 2. Anything outside by itself pushes it the y direction. So I'm going to go right 2, down 1. Right 2, down 1. And then it's got a positive 1 slope because this is just a plain x here. And there's your v. All right, so composite functions is the last part of the notes. I might have to cut this off. I'm getting ready to start the next class, so hopefully I can finish. So a lot of times we see this, and we call this fog, because this is an open circle, or we see golf. I always call it fog and golf, okay? Anytime you see this open circle, it's f of g of x, okay? And so that's what we're going to find here. Okay. So this is really the last example. We're going to find f of g of x. What I always recommend, take the inside parentheses. What does g of x equal? G of x equals x squared. So I'm going to replace g of x with x squared. Now, what does f of x equal? If f of x, notice when this is just x, equals x minus 7, what does f of x squared equal? See how, here I'm going to put this part right here. Whatever on this side, the left side of the equal sign, replaces what's on the right side. So if this is x, the right side is x. If the left side is x squared, the right side is x squared. The left has to match the right. Okay? Then it says, what is f of g of 2? All right. So you can do this a couple of ways. What is g of 2? Well, we can go back to the g function. If g is x squared, what is 2 squared? That is 4. So g of 2 is 4. Then find f of 4. So go to the f function. 4 minus 7 is negative 3. All right, I'm sure that you have questions, and we will address them tomorrow or the next day. So please jot them down and we will go over them.